Hello, today we're talking about Unit 7 functions, and we're going to try and solve/graph a function without the use of technology. Example number 1 asks you to graph two functions on the set of axes provided. And to do that, we're going to start by creating a table of values for each of those functions. And then we're going to go ahead and start with the graphing. So I'm going to begin with the function f of x. And I'm going to create a nice table of values that gives us a good idea of what the function looks like. So I want to use a very wide range of inputs so I'm certain that the graph's picture looks like it should. And so I'm going to start all the way down at, I don't know, we'll say -3. And we're going to try every single input, every integer input, starting from -3, and we'll go up to about 3. And we're hoping that that gives us a nice picture of what the graph should look like. We saw in a previous video how to calculate outputs from inputs. So if that's something that you're struggling with, go back and watch one of the previous videos. But basically, you're going to insert or substitute the x value from the table of values into the function to produce a y value. So to get us started, we're going to plug -3 in place of x and find out what 2 times -3 minus 2 is. And that turns out to be -8. I'm going to proceed in this fashion, plugging each input in to yield an output. Feel free to use your calculator to make this happen. Once we've constructed the table of values, now it's just a matter of plotting those ordered pairs on the coordinate graph next to it. So for example, -3, -8 is one of the input-output pairs for the function f of x. So I'm going to count over to -3 on the x-axis and down to -8 on the y-axis, and I'm going to put a point there. So that's -3, -8. I'll do the same thing for the rest of the table of values, plotting each xy pair as a point on the graph. Once I have the table of values plotted, then I ask myself, are there values that I'm not showing in the table of values but are still valid for this function? As an example, could I plug 4 into the function and get a value? Of course, the answer is yes, because 2 times 4 minus 2 is 6. So technically speaking, I could also plot the value 4, 6. I could also plot the value 5, 8. And I could keep going in this way. So instead of plotting all of those points along the graph, because there would be an infinite number, I instead draw a line through the dots showing all the points in between and extending in both directions would also be input-outputs of this function. Hence the line, hence the arrows. I'm going to do the exact same thing for g of x. So again, I'm going to choose a couple xy values to use as my input-outputs. This time I'm going to choose a few more just to make sure that I get a nice picture of this function. So I'm going to start all the way down at -5 for an input and end all the way at +5. Again, use your calculator for this portion of things if that helps, particularly if you're not able to do this math mentally. -5 inserted into the function g of x gives me -5 minus 3, which is -8, which when we square we get 64, and then we subtract 1 to get 63. I'm going to pause the video and complete the rest of the table. You should do that too, and then we'll come back and check together. Alright, you'll notice that I've completed the entire input-output table from -5 to 5, all the integer inputs. And hopefully yours looks like mine, if you did all your math correctly. Be careful with those squareds, of course, with negative numbers. And I'm going to start plotting the points. You'll notice that the point -5, 63 is way, way, way off the graph. And so for that reason, I won't be including it. I'll only be including the points that actually show up on the axes. So it looks like the first one is 0, 8. I'm going to put a point right there. 1, 3, 2, 0, 3 comma negative 1, 4 comma 0, and 5 comma 3. Now, we can see it in the table as well as if we sort of use our intuition. If we were to insert more values for x, we would get even more outputs, including decimal values. So, for example, if we plugged in 3.5, we would expect to get some value between negative 1 and 0 as an output. And so for that reason, we'll connect all of the points with a line. And we'll also draw arrows at the end indicating that the graph continues in that direction. And we've now graphed both functions on the same graph. You can complete the rest of the problems on your own and check with the answer key.